So the general pattern of this process is that if I were to generalize the entire process until it goes to 1, what happens is that the number is multiplied by 3 to the power c divided by 2 to the power a series of numbers, let's say a1, a2, a3 until ac, where these numbers are those in which every single time, whereas these a1, a2, a3 until ac are the numbers which represent how many times the number is going to be divisible by 2, that power. So this is just the process of just a part of the multiple of n, and then it's added to 3 to the power c minus 1 with the same division, which is a1 plus a2 plus a3 until a to the power c, and then 3 to the power c minus 2 with the removal of a1, we get 2 to the power a2 plus a3 a4 until a to the power c, and by the until it reaches 3 to the power 0, which is 1 divided by the final number, I mean the final power of 2 by which it will be divisible, by which at the final steps the number will be divisible. So this is the entire process that happens in this algorithm. And earlier I said that when we take n as much larger than 2 to the power 60, this part is still very small in comparison, becomes very small in comparison. So for example, in case of 7 we have 3 to the power 5 divided by 2 to the power 11 plus 3 to the power 4 divided by 2 to the power 11 plus 3 to the power 3 divided by 2 to the power 10 plus 3 to the power 2 divided by 2 to the power 9 plus 3 by 2 to the power 7 plus 1 by 2 to the power 4, and all of this is equal to 1. This is what happens when n is equal to 7. When n is equal to 7, you multiply it by 3 divided by 2, add 1 and divide by 2, so this part, and then you keep repeating it again until it ends up being at 1. So you can check this is actually correct. This is actually what happens in the process. Let's just say that we are not going to go to 1. Even if we are to end at some point in the entire algorithm and don't go directly to 1, we still end up with an equation that looks something like this, something similar to this exactly. It is still in the form of this, with the exception being that we do not go to 1. So let's just say that instead of going to 1, so what happened is that I multiplied by 3, add by 1, and keep dividing by 2 to the power of 2, and until the point I did it, until the last step. This represents the last step where I stopped and did not go to 1. It will still be this number, and let's just say that this is actually equal to n. Let's just say instead of going to 1, I am going to assume that this is actually going to repeat itself after a point. If it repeated itself after a point and this is equal to n, what would happen is that this n and this n is the same number. I started with n and I ended up at n, because I am assuming that the number repeats itself. And now, because I know that we have already calculated up to the point of 2 to the power 60. We know that n cannot be less than 2 to the power 60. Now taking that information, knowing that information, let's just factorize all of this. Let's say that this all of this sums up to x. Let's say I have 2 to the power x, and this is 3 to the power c into n plus 3 to the power c minus 1 into nothing, 1 plus 3 to the power c minus 2 into, because a1 was removed, I get a1, 2 to the power a1 plus 3 to the power c minus 3 into 2 to the power a1 plus a2, and so on until I get to this point where you multiply it by, you get 2 to the power x minus ac, and let's say this is equal to n. I would multiply this on the other side, we get 3 to the power c into n plus 3 to the power c minus 1 plus 3 to the power c minus 2 into 2 to the power a1 plus 3 to the power c minus 3 into 2 to the power a1 plus a2 dash 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 2 to the power x minus ac equals to n multiplied by 2 to the power x. And let's just say I am going to take this to the other side. I get 3 to the power c minus 1 plus 3 to the power c minus 2 into 2 to the power a1 plus 3 to the power c minus 3 into 2 to the power a1 plus a2 dash 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 to the power x minus a1 is equal to n into 2 to the power x minus 3 to the power c. So I get, I'm going to take this and this to the opposite side. So I have 3 to the power c minus 2 into 2 to the power a1 plus 3 to the power c minus 3 into 2 to the power a1 plus a2 until 3 to the power 1 into 2 to the power x minus ac minus ac minus 1, which is equal to n into 2 to the power x minus 3 to the power c minus 3 to the power c minus 1 minus 2 to the power x minus a1. So this is what I end up with. And let's just say that this is what I need to equate to this in order for me to have a number that ends up at itself, or in other words repeats itself. So let's check what's actually happening. I have a number that is 2 to the power x, and I'm subtracting 3 to the power c from it, and then I'm multiplying it by n. Remember that n is going to be greater than 2 to the power 60. N has to be greater than 2 to the power 60 because we already know that these numbers have already been calculated to go to 1. So if there is a number that repeats itself, it has to be above this number. So this and this, what I found out is that in order for me to evaluate the worst case scenario in this equation, you will find is that even in the worst case scenario, this can actually never equal to this, because this will always be much larger in comparison to this. And to prove that, let's just take this number to be let's just calculate the worst case of this number. For me to say that this is going to maximize, for me to because I am saying that this is always going to be less than this, let's say I am going to maximize this and minimize this. So because I know that I need to minimize this, I must make sure that these numbers must be as large as possible and this must be as small as possible. So to make this as small as possible, what you will find is that when you go to a number that is much higher, if I say that x is a number greater than big numbers, when we talk about big numbers, let's say x is equal to 30. When we go to, because we know that generally the algorithm, generally what happens is that this procedure takes a long time, more than 30. So let's say it is C is more than 30, or maybe let's say 20. So what you will find is that if I take x is equal to C, x is equal to 30, for you to and we know that this has to be positive, this cannot be negative, because we know that we are going to end up at the same number, which is n, and n is a positive number. All of this has to be positive, and for me to merely remain positive using this, for me to barely remain positive in this using this number, if I am taking x is equal to 30, I am forced to take C minimum as if I am to take x is equal to 32, let's say, I am forced to take a minimum of 20. Or in other words, if I say that C is equal to 20, I am forced to take x a little greater than 3/2 C, little greater than, nearly equal, for me to barely remain positive in the positive spectrum. I have to be, at the very least, at the very minimum, x has to be greater than 3/2 into C. That's the cost of it being positive. And I know, and remember that I'm minimizing this. So I'm taking the minimum for it to be minimum, x has to be 32. So if x is equal to 32, then this, let's say, because I'm maximizing this, let's say AC is equal to 1, which gives me x minus AC as 31, and this is equal to 19. C minus 1 is equal to 19. C minus 2 would be 18. And for me to maximize this whole equation, I must maximize this thing, because this has to be as large as possible. When this is as large as possible, rest of it is not going to matter, because when you decrease exponentially, then addition is not going to make a difference. So in order to maximize this, let's say A1 plus A2 is how much A1 plus A2 can be in order for it to be maximum. Because this is n minus 1 terms, because I know that all of this is C minus 1 terms. This has C minus 1 terms at the minimum. So I am going to subtract C minus 1, which is 19, from from this number, which gives me 31 minus AC minus 1, let's say 1, let's say this is 1, so gives me 30. So this, let's say this is 30. When I subtract C minus 1 from this, I get 11. So this cannot be larger than 11. This is 18 and this cannot be larger than 11. Because this is not larger than 11, I have 3 to the power 18 multiplied by 2 to the power 11 on this hand, and on the other hand I have n multiplied by 2 to the power 32 minus 3 to the power 20 minus 2 to the power 31 minus 3 to the power 19. So what I found out is that this is what you will find is that no matter what value of x you take, what happens is that this number is always equal to near about 2 to the power 31. This number actually ranges from x minus 2 to x minus 3. This number 2 to the power x minus 3 to the power c. This actually ranges from x minus 2 to x minus 3. No matter what value of x you take. So in this case, this is nearly equal to 2 to the power 29 and 2 to the power 30, in between. It is in between these two numbers. And this actually ends up being, this actually ranges from 31 to 2 to the power 31 to 2 to the power 32. In other words, this number 2 to the power 31 plus 3 to the power 19, or 2 to the power x minus ac plus 3 to the power c minus 1. This is actually nearly equal to 2 to the power x minus ac plus 1, or 2 to the power x minus ac. This ranges from this and this. This number actually ranges between these two numbers, no matter what value of x and c you take. What I'm trying to say is that I can generalize this and write it as x multiplied by 2 to the power x minus 2 or x minus 3, and subtract 2 to the power x minus ac or minus 1, x minus ac minus 1. And because I know that n is 2 to the power 60 or larger than 2 to the power 60, I know that this is a much larger number than this. I know that this, even if you subtract this number from this, it's not going to be a matter. It's not going to make a difference. So I have 2 to the power 60 multiplied by 2 to the power x minus 2, let's say x minus 3, on one hand, and on the other hand I have a maximum of this. 3 to the power 18 multiplied by 2 to the power 11, or 3 to the power c minus 2 multiplied by 2 to the power x minus ac minus 1 minus c minus 1. This on one hand I have this number, this is a fairly large number, and on the other hand I have this. So I have to check, in order for me to prove that this is always going to be smaller than this side, I just have to prove that this number is actually much smaller in comparison to this. So when you calculate this, you will realize that 3 to the power 18 multiplied by 2 to the power 18 is nearly equal to 2 to the power 40. Or 41. This actually ranges from 39 to 40. In other words, it is 4/3 of x. Whatever x you take, let's say you take x is equal to 32, you divide by 3 and multiply by 4. That's what the maximum of this is going to be. Maximum of the 3 to the power 18 multiplied by 2 to the power 11 is going to be 3 to the power 41 to 3 to the power 39 to 40. This is what it ranges in between. So because I know that, I'm sorry, 2 to the power, not 3. And because I know that the number n is already to the power 60, and the number which I am multiplying it by is 2 to the power x minus 2, at minimum I know for a fact that this is always going to be smaller. So let's say that even if you take 60, you can check this, even if you take x is equal to 60, you get the same results. No matter what value of x you take, you are going to get this exact same result. So we know that 3 to the power x minus 2 to the power y we know that 2 to the power x minus 3 to the power y, for this to be minimum, y needs to be equal to x multiplied by log 3 over, no, log 2 over log 3. This is calculated by just putting it equal to 0 and getting the value of y in terms of x. You will get this value, and and this is, and because if y is equal to this number would be exactly equal to 0, therefore we take the floor of this number. We don't take the number itself, we take just the floor of this number. And basically x multiplied is something like 0.69, x multiplied by 0.69 something, and then the number, whatever number comes about, you, whatever number, say 37.6489, whatever number comes about, you just ignore this part. You would ignore the part after decimal, and if this is going to be your integer. That's going to make it minimum. And in the same way, you can check for the 2 to the power what minimum equals to by calculating the minimum in by doing differentiation and calculus. A bit of calculus, you can calculate what power of 2 is going to be. You can check this with your calculator. This is always going to be true, that the maximum that the left hand side can reach is 2 to the power 4 by 3 into x, and the minimum that the right hand side can go to is 2 to the power 60 multiplied by 2 to the power x minus 2. Therefore, this is always going to be larger, and that's the reason why it is never going to repeat itself. That's the reason why above 2 to the power 60, this procedure is never going to repeat itself.